100% of people got this question right.
Pyruvate molecules containing carbon-14 labeled carboxyl groups are added to a cell capable of oxidative phosphorylation. Which molecules produced least likely contain carbon-14 in the cell? So it says that the cell can do oxidative phosphorylation. So that means, it can do the typical glycolysis, gluconeogenesis, but can also do things like participate in the TCA cycle and all those other things, right? And so let's start with pyruvate here, and we're going to see during any of these processes, like what happens to this specific carbon, right? This is the radio-labeled carbon-14 that's part of the carboxyl group. So let's start with oxaloacetate. Converting from pyruvate to oxaloacetate involves pyruvate carboxylase, and this occurs in gluconeogenesis. And essentially, as the enzyme name suggests, we're just carboxylating pyruvate. So we're adding a COOH group, something like that, right? So it's going to look like this right here. And look, this carbon-14 is still there. So oxaloacetate will most likely contain carbon-14. Now, looking at glucose, right? This process is to ultimately end up in glucose, gluconeogenesis, right? So the next step of this would be using phosphoenol pyruvate carboxykinase, and this is going to give us phosphoenol pyruvate. So it's going to look something like that, right? And so look what happened. This carboxyl group is gone, and we replaced it with this PO4. But look, this is still here. This is the original carbon-14, and then we released that carboxyl group as CO2. But the idea is that this is still here, and all the rest of the steps in gluconeogenesis, where we ultimately end up with the glucose. This carbon is still going to be there. It's just that it's going to be shifted around, and the carboxyl group will change to like aldehyde or whatever. But this is still going to remain. So glucose would most likely contain carbon-14 as well. So this is incorrect. Now, look at this acetyl-CoA CO2, right? We just talked about CO2 being released, and this did not contain this carbon, but this could still be correct. And let's talk about why. Let's talk about acetyl-CoA first. This will help us understand. When we're going from pyruvate to acetyl-CoA, let's draw acetyl-CoA. Acetyl-CoA looks like this. And this is, when we're trying to go into the TCA cycle and that type of stuff, we have to use an enzyme called pyruvate dehydrogenase, and then CoA, this enzyme CoA is going to come in, help form this. And you're going to release CO2 like this, right? Look what happened. This acetyl group is still there, but this carboxyl group with this carbon is gone. It got replaced with S-CoA. So that means that this, I'm going to emphasize this right here. This CO2 does contain the carbon-14. So that means that B is incorrect because it can contain it, right? But acetyl-CoA, there's no way, because acetyl-CoA does not have the carboxyl carbon.